Hi, I'm about to show you how to sketch a polynomial if you know the standard form and the factored form. So I have two examples here, j of x and g of x. I'm going to work through them simultaneously, one step at a time. So if we're sketching our polynomial, the first thing we need to know is its end behavior. So to determine the end behavior of a polynomial, we need to look at the standard form. So I'm going to look at my standard form for both of these examples. And the end behavior is dictated by two things. It's dictated by the leading coefficient. So in j of x, my leading coefficient is negative, which means that on the right side, this polynomial is going down. As x approaches positive infinity, the function is approaching negative infinity. And in g of x, my leading coefficient is positive, which means as x approaches infinity, g of x will also approach infinity. So the leading coefficient tells me the behavior on the right side. And then the degree of my standard form tells me whether these two sides are matched or mismatched. So in j of x, the degree is even, which means both sides will go to negative infinity. In g of x, the degree is odd, which means the two sides are mismatched. So step one is that standard form tells me my end behavior. And I'm going to give myself that end behavior so that I know where my sketch begins and finishes. Second thing I need is I need to determine the zeros, or the x-intercepts, of my graph. To determine the zeros, I'm going to look at my factored form. So in j of x, my zeros will be when 2x minus 7 equals 0, or when x minus 1 equals 0. Negative 3 on its own can never equal 0, so in j of x, I'm going to have two zeros. To find the actual x-intercept, I'm going to solve these two equations. So I get x equals 3.5 and x equals 1. So that tells me that my x-intercepts for j of x happen at 1 and 3.5. For g of x, I have three roots. I have three opportunities to equal 0. Either 3x squared equals 0, which would tell me that x equals 0, or 2x minus 7 equals 0. We already have the work for that, so that tells us x is 3.5. Or x minus 1 equals 0, in which case x would be 1. So for g of x, my zeros happen at 0, 1, and 3.5. And I'm going to label those. So now I have my end behavior, and I have all of my zeros labeled for both functions. The last step will be to determine at each zero whether I'm dealing with a bounce or a cross. So the thing that determines whether something's a bounce or a cross is the multiplicity. Bounces will happen when the multiplicity is even. A cross will happen let's do this. A cross will happen if the multiplicity is odd. So I go back to my factored form for this, and I just check the multiplicity of each of my roots. So looking at j of x, there are no even multiplicities. Negative 3 is to the first power, 2x minus 1 is to the first power, x minus 1 is to the third power. So all of my multiplicities in j of x are odd, which means everything is going to be a cross. I'm going to cross the x-axis at all of my zeros. Versus g of x, I have an even multiplicity twice. So that means I'm going to have a bounce here. I'm going to have a bounce here. And then since this one is an odd multiplicity, I will have a cross. So even multiplicities give me a bounce, odd multiplicities give me a cross, and I'm looking in the factored form when I'm looking at those multiplicities. So on g of x, if I label that here, I'm going to have a bounce. I'm going to have a bounce. And then in the middle one, I'm going to have a cross when x equals 1. So now I have all the information I need to make my sketch. Once I have all this information, this is when I'm finally going to actually connect the dots. I have my end behavior, I have my zeros, I know where I'm bouncing, I know where I'm crossing, so I'm just going to follow my own instructions. I'm going to start at my left end behavior, and actually let's make this green to match our function. Start at my left end behavior. I'm going to travel towards my first x-intercept, and then it's telling me that this is a cross, so I'm going to go across the x-axis. I'm going to keep going. Then I'm going to turn around up here because I need to return to my next x-intercept. As I approach it, it tells me this is another cross, so I'm going to cross and reach my other end behavior, and now I have sketched j of x. I have zeros. They match the multiplicity. They are both crosses because they're both odd. And I have a beautiful sketch. For g of x, I'm going to do the same thing. I'm going to start at my left end behavior. I'm going to travel to each zero, and then I'm going to follow my own instructions. For this first zero, we know it's bouncing because it's x squared. That's an even multiplicity. So instead of crossing the x-axis, I'm going to touch that zero and then stay where I am. Then for my next zero at 1, 0, I'm supposed to cross because I had an odd multiplicity. So I'm going to go up, and then instead of bouncing off, I'm going to go touch that x-intercept, and I'm going to cross the x-axis. Like that. And then finally, I'm going to return to my third x-intercept. This one is a bounce, which means I'm going to touch it and turn around. And then that should bring me to the end of my end behavior where I already knew it was going to go. And this is my sketch of g of x. So to summarize, the standard form, the first term of your standard form tells you your end behavior. The factored form tells you your roots or your zeros. And then the multiplicity of those roots tells you whether they are a bounce or a cross. Combining that information, you can make the sketch of your polynomial.